Hello, hello, puppets. Let's learn some more math today. All right, guys, we're going to do some adding and subtracting of radicals today. But before we do that, you need to practice. You guys got to keep working through this stuff till it becomes a rote thing. You just got to keep working it till it's in your bones. So pause it, do those problems. You got to practice your exponents. Go. All right, I'm going to dive in and do these behind you. If you didn't do these yet, pause the video and do them. Watching me won't teach you anything. And there's a quiz this week on Thursday on all of this stuff. So if you know you need to learn this and work at it still, you need to do them before I do them. All right, here we go. This is simply power of a power, real simple. So we're going to multiply, okay? That's saying 4 groups of the negative 3. Multiply to make negative 12. Can't leave a negative in your exponent answer. You can't have any negative exponents. So remember, a negative means to rewrite it, and it flips to the other side of the fraction. If it's on top or if it's not a fraction, that whole piece goes to the bottom. If it were a negative on bottom, you'd flip it back to the top. Number 2, power to a power again, and we're going to distribute this guy to each piece of that term. So we have 5 to the negative 2 now. X to the negative 6, and then y to the 0 times negative 2 is still going to be y to the 0. Remember, anything times 0 is going to stay that value. From here, that 5, to get rid of the negative, needs to become a 5 squared on the bottom. The x, to get rid of its negative, needs to go to the bottom. And y to the 0, anything to the 0 just equals 1. So we can just cancel that off. It's just going to go away. So there's nothing left on top, but we have to put something there to keep its place. So it's always 1, the invisible 1, and then we can finish with that 5 squared. So it's really just 25x6. 1 over that. There you go. Number 3. I'm going to start with just the values. Negative 8 over 16, that's just negative 1/2. My x's here, 2 and negative 5. I'm going to bring that negative 5 up to the top. So I'm actually going to have an x2 and an x5 together on top of the fraction, and then that's going to add because they're common bases, and the common bases multiplying means we're going to add their exponents. So that becomes x to the 7th up on the top. Now if I do the y's, I would bring this guy down to the bottom, so we would have the y to the 5 and the y to the 3 together now on the bottom of the fraction, and those also would add, which gives us y to the 8 on the bottom. If you wanted to leave that 1, that's fine, but you don't need to. It's also the same to just say negative x7 over 2 to the 2 times y to the 8th. All right, number 4. X to the 0, I'm just going to cancel that. And then the 3 times the negative 5 there, so negative 15. And then I see I've got an x to the 4 here. That's the only x left in the problem, so I'm just going to bring that down to the answer. And then my y's, the y to the 3 here, since it's negative, is going to go to the bottom and be y to the 3 on bottom. The y to the 5, I'll just leave on top. And now I can finish those y's. That's actually a subtraction, 5 minus 3. So I've got the negative 15x4, and then the y5 minus 3 is y to the 2nd. All right, I'm hoping this stuff is making sense to you guys. This is exactly what it'll look like on Friday's quiz. Okay, the other piece of the quiz, the other piece of this unit is our radicals. So let's just take a minute, same exact thing. You're going to simplify these. Some of them might be perfect squares. Others you're going to need to do the simplifying by pulling out whatever perfect squares you find inside, like yesterday's homework. Give it a shot, go. All right, let's jump in and look. 49, well, that's just 7 times 7. We could start and break it down. The only thing that multiplies to 49 is 7 times 7, so it's a perfect square, and there we go. We see 7. Number 2, we're working variables here, and remember the unwritten value there for the radical means it's a square. It's 2 there, so I'm looking for groups of 2. If I was going to write that out, there's 7 x's, so I'm taking groups of 2 out because it's asking for square. It's asking for groups of 2. So there's 3 x's that would come out. Okay, so I could think of it as that way. All 3 of those circled pairs of x's take their square root, they come out. But we're not going to write xxx on the front. We're just going to write it as x cubed because there were 3 groups that we took out there. And then there's 1x left over. He's going to stay under the radical. And then y's. Now if I shortcut that, instead of writing it out like I just did with the x's here, if I just think of the y's and don't write it out, I'm just going to say there's 3 of them. 1 group of 2 comes out. Taking its square means it's 1 y on the front. And out of that 1 group of 2, there's 1 of those 3 left over. It stays underneath. All right, there you go. Number 3, notice we're doing a cube root. So if we break down 8, that's 2 times 4. 4 is 2 times 2. So there's 1, 2, 3 2's. Taking the cube root of that 8 means it's a 2, and the 8 disappears entirely. All we've got left is the p's in there, and there's 7 of them. So if I take 2 groups of the 3 out, and you know what? We should be making this a little clearer, because there's going to be a certain amount of p's, and you're going to have a cube root that you need to write up, so it needs to be a little clearer. That's the cube root. That's the p's I'm taking out, and I took 2 groups of 3 out, which is 6 total, leaving only 1 of the 7 underneath. Anybody's unclear? There's 1 group of 3. There's another group of 3. To take each of them out makes 2 p's. That's 2 groups I pulled out, and there's 1 of the 7 left over. All right, number 4. 27 is 3 times 3 times 3, or you could do 3 times 9 and then break it down. It's a square root, so 2 of those guys come out. So a 3 gets taken out front from that set of 3's when you take the square root, and 1 guy's left underneath. M3, 1 pair of those 2 m's comes out, and his square root makes him an m out front, and then there's 1 of that 3 left underneath. 60, let's see, 6 and 10. 6 is 2 and 3, 10 is 2 and 5. Okay, I have a pair of 2's I can take out of that 60, so they come out front. And then the 3 and the 5 are left over, which multiply back together to make a 15. X, I can't take the x out, there's only 1 of them. And y to the 5th, I can take 2 groups of 2. So there's the 2 groups of 2 after I take their square. And then there's 1 of that 5 left over. After I take away 2 groups of 2 making 4, there's 1 of the 5 left over. All right, let's see, 88. That's 8 times 11. 8, 4 times 2, and 4 is 2 times 2. So I've got 1, 2, 3 of the 2's and an 11, but I need a 4th root. I can't take anything out for the 88. So the 88 has to stay underneath because there aren't 4 of anything inside of it. P5, I can take 1 group of 4 p's out, and that becomes a single p outside after I take the root, and 1's left under. X to the 9, I can take 2 groups of 4 out with the x to the 9, and again, I just ran into trouble with it being too close, so I'm going to rewrite it down here. You guys need to work on being neater, so I'm going to do the same thing. This is a 4th root problem. I took 2 groups of the x out, which is 8 of the 9, leaving 1x underneath. And there you go. All right, I hope this is making sense. We're going to build on this and use it today. Okay. Adding and subtracting radical terms. Before we get to that, we're going to look down memory lane a little bit. Okay? Do you guys remember? This is just our like terms learning. This is old hat. This is very simple by now. Remember this. Okay? If we add this together, what are you guys going to get? Negative 6x plus 8x. Hopefully, really obviously, you're going to say 2x. Okay? And if I try to do the second problem, 14x plus 12y isn't going to combine because they're not like. So that's it, 14x plus 12y. I'm not going to go any farther than that. I can't do any more. Let's apply that same idea right next door to fractions. 3/7 minus 5/7. Well, sevenths and sevenths are going to continue to be sevenths. That's the size of the piece. So we're really just doing subtraction with the top. 3 minus 5, which is negative 2. And on the bottom here, 2/5 plus 3/6. We can't add this, not in its current form, because they're different size pieces. In a sense, they're unlike. So if we were going to add these, we would have to do some work to modify the fractions. We would rewrite them into a like size piece. I'll multiply this side by 6 to create 30ths on bottom. And that means I have 12 on top. I'll multiply this side by 5 to get those 30ths on bottom, which gives me 15 on top, and now I can add them together to get that 27/30ths. Now, look at the concept that's kind of being pointed out here. In terms of variables in like terms, if they're like, you're able to add them together. And whatever you started with is what you end with for that term, okay? If they are unlike, we can't do any work because we can't put together x's and y's, so they stay separate, okay? This is all in terms of adding and subtracting. Same thing with fractions. If they're like, I'm combining groups or taking apart groups of the same size, it works. I can figure out a new total or subtract some of those away if they're all the same size I'm working with. But if they are unlike in size, we either can't do it or we have to do some work to rewrite it into a like size, and then we can move on from there, okay? And notice also what you're actually combining when you've got like pieces is that coefficient on front. Those are what get put together. Or here, the tops of the fractions, those are what create your new total. So take that concept and over here. If 3/5 plus 4/5 equals 7/5, okay, it's just what we saw there a minute ago, but now I'm just highlighting it in color, or the negative 6x plus 8x. It's going to be some number of x's. Negative 6 plus 8 is 2x, okay? We see that like piece that has to follow. What do you think is going to happen when we have to combine radicals? Negative 6 radical 7 plus 9 radical 7. I'm going to let you take a minute. What do you think that's going to equal? Hopefully, number one, you're able to connect that radicals are just like these other groups, okay? Fractional fifths have to be like, and then we can add the other piece. Like term variables, those are like, which lets us add together the coefficients. The same principle is true here. Radical 7, okay? It's a number, so in a sense, these are like terms, because whatever a radical 7 comes out to, it'd be something between radical 4, which is 2, and radical 9, which is 3. Those are the perfect squares on each side. So it's going to be 2 point something, something, something. So whatever that is, negative 6 times that, and then 9 times that, as long as they're like, we can put together the negative 6 and the 9 and say, oh, we're going to have a total of 3 of that number, whatever that number is, 2 point blah, blah, blah. And so we can treat it just like a like term. As long as they're like, you're able to add or subtract them. They have to be like. Okay? So, let's throw in a random fact. You knew it was coming. The U.S. Navy has started using Xbox controllers for their periscopes. Not PlayStation controllers. Just saying. I'm an Xbox guy too. All right. So, let's try some of these right now. Why don't you guys take a minute and apply that concept from just a minute ago. We have like radicals, so it should be very easy and straightforward to get that new answer. Go. All right, I'm jumping in behind you. If I see radical 10, I know I'm going to stay with radical 10. It's just a number of radical 10s I'm adding or subtracting. Negative 7 plus 8, that's 1 radical 10. And a 1 in front, you could even just leave as radical 10. There's that invisible 1, either way is fine. Here we've got radical 6s, so I'm combining those just like terms. Negative 11 And negative 7, bad guy, that's just negative 18 radical 6. Next one, it works the same way with variables. I'm adding together radical xy's. As long as they match, I can leave them just like that. 21 minus 8, what's that, 13? So we get 13 radical xy. And last, did I catch you with this one? Did you notice? I hope you did. There isn't a like radical. You can't put those together. We can't do anything. It's as simple as it's going to get, unless we have a way to work with radicals, or at least some radicals. If there was a way to maybe rewrite these, simplify these into another form, then maybe we could get them to match, and then maybe we could add them together. Let's see. Okay. How can we add or subtract unlike radicals? And the answer is just like we do fractions, and actually just like you guys have already been doing with your radicals. We already learned how to rewrite them when there's a perfect square that might be inside of them, and then simplify and pull that stuff out. Once we do that, we can go another step further, and we can add them together or subtract if you end up with a like radical for both. So let's try it. Radical 12 minus radical 75, not like, can't do anything unless we can rewrite these guys. Let's just see what happens. We'll apply that skill we already know. A 12 is just a 6 times 2, and a 6 is a 2 times 3. Oh, well, there is a pair of 2's. So I could think of that radical 12 as a 2 radical 3. The 2 times 2, 4, or the pair of 2's. You can take that square root and it becomes a 2 out front, radical 3 underneath. Maybe I can rewrite that 75 into a radical 3, and then they're like. That's a 25 times 3, and 25 is a 5 times 5. So there you go. I've got 2 5's, and again, that 3. So minus, I can pull the 5 out front. The 3 stays underneath. And so now, I've got exactly what I need to make this work. I rewrote both of them into radical 3's. Now notice we're not done. It's just like a fraction problem. We rewrote it, so now we can answer it. 2 radical 3's minus 5 radical 3's. Well, 2 minus 5 is negative 3. And the term, the type of item we're combining is radical 3's. There you go. All right, let's do another one. 28. Well, let's see. That's a 4 times 7. And a 4 is a 2 times 2. So there's a pair of 2's I can take out. And notice I've already got a negative 3 out front. So if I pull that pair of 2's out, there's the 2. And then I already had the negative 3 there. And then what was left underneath was a 7. And as far as the x goes, there's only one of them. I have to have at least a pair, so the x can't come out. It stays underneath. And out front, these are all multiplied together. We have the negative 3 times the radical to begin with. They're written right next to each other. It's just like the rule with parentheses. Anything written next to something else, it's assumed is multiplication. And if we pull that 2 out, okay, he came out of here when we took the square root. So he's also multiplying. He's part of this term. So those are just going to go together, and we end up with a negative 6 radical 7x. Okay? So whatever comes out is going to multiply with anything already on the front. Let's try it again. 63. 9 times 7, and that 9 is just 3 and 3. So there's our pair of something we can take out. So it's going to be negative 4, if I can keep my color coding here. We've got the negative 4 that was already there, and then I'll put the 3 on the back. It doesn't really matter. They're going to multiply together, so that pair of 3's becomes a 3 out in front to multiply. And what's left underneath, we've got the 7 that couldn't come out, and we've got the x. So a couple of things to notice. They're like now. We are able to finish combining these guys in this problem. And then the other thing, don't forget, put these together. Those two terms, those two coefficients now, they multiply together, so it's actually a negative 12. And so now we can go to a final answer. We've got a negative 6 and a negative 12. So combine them together, it's a negative 18 radical 7x. And there you go. Okay, one more example. Same idea. Hopefully this is starting to make sense, and you guys are getting the ability where you can kind of jump off and do this. That 4 is just a 2 and a 2. The 6 is a 3 and a 2. So I can pull out one pair of 2s onto the front. So there's the -5. And there's the 2 I pulled out. What's left underneath is that 3 times 2. There's only one of each of those, so that stays underneath as a 6. And that'll become a -10 radical 6. That's as far as we can take that one. Here, 44, 4 times 11. 4 is 2 times 2. So plus, there's nothing out front, so just that 2 that comes out. And then what's left underneath is that 11. And that didn't work out, okay? We've done all we can do. But in this case, there is not a radical. There's nothing, once they're simplified, there isn't anything like there. So that's as far as we can go. That one is simplified because we can't do any more. So in this case, radicals are a little different than fractions because you can always write fractions as a common denominator. Any two fractions can be added or subtracted. It's not the case with radicals. Sometimes you pull out what you can pull out and you don't have a common radical that you're going to be able to work with. So that's as far as you can go. All right, there's a few practice problems. Pause me and practice those 3 and turn me back on in a minute. All right, let's take a look. 5 is as far as it's going to go. So this is kind of a hint to you for what you should be looking for on the other radical if they're actually going to work out. They're going to have to become 5s. And we pull out that 45 into a 9 times 5, and the 9 is 3 times 3, and there's our pair. So we have the radical 5 from the front term, and then that pair of 3's comes out -3, and what's left underneath is the 5. So now we do have that like radical, and if anybody got thrown, remember there's always something out front to do the adding or subtracting. Good old invisible 1, so it turns out we can finish this. It's 1 minus 3. So we have -2 radical 5. All right, next one. 32, we got an 8, 4. There's a 4 times 2. There's a 2 times 2. Holy cow, this is just a whole bunch of 2's. 1, 2, 3, 4, 5 2's at the end. And we can, since it's a square root, we can pull one pair of 2's out. We can pull a second pair of 2's out. So there's the -4 that was on front. And then I'll write all of it out so you guys see what's going on this one. There's one of the 2's I pulled out. There's the other pair of 2's I pulled out after I take the square root. And what's left underneath out of that 32 is just the 1, 2 left over. This one guy that couldn't go into anything, so radical 2. So this one needs to become radical 2 as well, or we're not going to be able to do anything here. So we got a 36 times 2. 36 is 6 times 6. Now I could keep going and get a 2 and a 3 and a 2 and a 3, and I could pull out a pair of the pair of 2's, pull out a pair of 3's, but why go that far? We just found a pair of 6's. Let's just stop there. Once you find a pair of something, you can pull it out. So -6, there's the original 6 in the problem. And then I've got a pair of 6's I found inside the number, so when I pull them out and take the square root, there's a single 6. And all that's left is that single 2, so it does work out. They do become like radicals. Now I just need to put all this together before I can do the subtraction. So I've got 4 times 2 times 2, so that's a 16 negative, right? Yep, -16, radical 2. And then the -6 times 6, -36, radical 2. And now you can actually finish this guy. I'll just keep going over here because we're running out of space. -16 and -36, what's that? 46, 52. -52 radical 2. All right, last one. Notice cube root, exact same idea, but look for 3 of things. So 54, I don't know off the top of my head, so I'm going to use that trick I showed you guys. 2 times anything that's an even number. Half of that is 27, and that kind of breaks this guy open. Oh yeah, 27, that's 3 times 3 times 3, I remembered. And so I see there is my cube. There's 3 of something, so I know what I can pull out. Shrink this down, see if I can do that. Yep. Give me some more room. So there's the 4 I had to begin with. Then the 3, there's 3 of them, so when I take that cube root, there's 1 of them left out front. This is a cube root problem, and the only thing left underneath, it's another radical 2 problem. Okay, and the 16 is just 2 times 8. 8's 4 times 2, and then the point being, the 16 just turns into 4 different 2's. 3 of them come out, so there's the negative 5 to begin with. 3 of those 2's become a 2 on the outside for the cube root. And there's only 1 2 left inside, so we do have matching radicals. And now we just finish it up. 4 times 3, we've got 12 cube root 2. Negative 5 and 2, we have negative 10 cube root 2. And we have 12 minus 10, 2 cube root 2. Okay. Is this starting to click and make sense for you guys? I hope so. All right. There is your homework. A few few exponent rule practice problems, because those just take a lot of just drill. They're pretty easy, but you just got to keep practicing. And then a few radical simplifying problems, like we just did today. And then a little throwback. Graph that line and notice it's not yet in slope-intercept form. So step 1, rewrite that guy so he's into slope-intercept, which means solve for y. So if you're not quite remembering, remember. You need this in a minute. And then once you're in that form, right, once you've got that, there's your m or slope, and then there's your b or your intercept. And that's where you can grab your pieces to graph. All right, go ahead and pause it. I think I will quickly work out solutions to this homework practice right now because it's just the easiest way to do it. So go ahead and pause, turn this back on when you're done to see how you did. All right, let's dive in. I see a pair of negatives I'm going to cancel. 27 divided by 3, that's 9. I see a y to the 0. Anything to the 0 just cancels. Oh, and look at that, z to the 5 over z to the 5. That's just 1. Anything over itself is just 1. That's also going to cancel. So all I'm left with is the x's. x4 over x negative 2. That negative 2 is going to come up to the top. So I would really write it like x to the 4, bring up the x to the 2, which means in the end it's actually 9 x to the 6. The bottom of the fraction goes away. Everything moves to the top or cancels out. All right, next one. I have this 4 that's going to distribute, but it's not going to go to the x0 because anything to 0 is 1. So it's the same as saying 1 to the 4th power, which is the same as 1, which is the same as whatever's next to it. So we can really cancel it and ignore it. So now we have negative 8 to the 4th power. And notice the negative was inside the parentheses, so it also gets raised to the exponent. And then we have p to the negative 12. We have to get rid of that negative. If you leave an answer like that, you'll lose points on the quiz. No negatives in your final answers. So it's going to be negative 8 to the 4th over p to the 12. And I'm not going to make you calculate that out because 8 to the 4th is 64 times 64, which is going to be way bigger than 200. That's our threshold. All right, next one. There's my straightforward numbers. That's a negative 54. And now I'm just counting up x's. I've got 2 there, and 5 there is 7. And instead of worrying about moving these negatives to the bottom on this problem, I'm just going to do the addition like I'm supposed to. So in terms of my x's, I have 2 on the first x, plus 5 on the exponent of the next one, and then plus negative 3 on the third x. So I'm just combining all those exponents because that's the rule when you're multiplying the common bases. 2 and 5 is 7, plus negative 3 is 4. So I have an x to the 4. And since that answer was positive, the negative goes away. There's no need to deal with it. It's just canceled because there were more positive x's than negative x's. All right, do the same thing with the y's. I've got 3 y's plus 2 more y's plus negative 4 y's, and that's 5 minus 4 is 1. So there's just 1 y left over, and everything's on top because there were no negatives, nothing on bottom. All right, Next, we're doing what we just did a minute ago. That's a 27 is what? 3 times 3 times 3. There's my pair. So negative 6 times the 3 that comes out, leaving 1 3 underneath. Minus 8 times whatever we can pull out here. Let's see. 6 times 8. 2 and 3. And an 8. I'm starting to think of 8s as just 2 times 2 times 2 when I break it down. So I've got 1, 2, 3, 4 2s I can pull out, which is going to need some room here because I really want to work on keeping things clean. I want you guys to do this as well. I'm going to rewrite things anytime I need to now to make it really simple and easy. I'm just rewriting the problem. Okay, I can pull 1 2 out. There it is. Then I had another pair of 2s. So I pulled that one out. And all that's left underneath is that 1 3 that doesn't have a buddy to pair with. And so now we have common radicals. There's the negative 18. And that's 4 times the negative 8, negative 32. I'll just put them all together. Negative 18, negative 32. What's that? Negative 50. Radical 3. All right. Keep going. 18. 9 times 2, and 9 is that perfect square, so I'm just going to stop there. And the 9 pulls out, becomes a 3, leaving me with a radical 2. So I need a radical 2 on the other side to be able to continue with this. 40, I got the 4 and 10, which is a 2 and a 2 and a 2 and a 5. So there's one pair of 2s I can take out. So that's 1 2 on front. And then what's left over is the 2 and the 5, which is the 10. Turns out I was not able to get that common radical, so I'm not able to finish this beyond saying negative 9 radical 2 plus 14 radical 10. That's as far as we can go because we don't have a common radical to continue combining. Last one, 32. Let's see, 16 times 2. And I'm going to stop there because I notice 16 is a perfect square. You could go farther and break it down into all the 2s, but either way, we should get to the 3 and then take out the 16. That square root is 4, leaving us just the 2 underneath. And the next one already is radical 2. There's nothing in there, which was kind of a hint to us from the beginning. That would have to be what we'd find on everything else to make them all work out, because radical 2 is as far as that one can go right off the bat. Plus 5 times, and we've got to see what we can find here. 25 times 2, there's my perfect square. Square root of 25 is 5, so there's another 5 out on the front. And all that's left inside is that radical 2. And now I'm just going to put all that together. I've got a 12 radical 2 minus a 7 radical 2 plus a 25 radical 2. And what's that going to give me? 12 minus 7 is 5. 5 plus 25 is 30. There you go. All right, last but not least, graph that line. I'm going to move that 4x over from negative, make it a plus 4x. So right here I can see it's a 4x and then it's a minus 3. So there's my m, there's my b. B is my intercept. So I'm going to start at negative 3 on the y-axis right there. And then my slope of 4, make it 4 over 1. So now I'm going to count 1, 2, 3, 4 up, 1 over. And for good measure, 1, 2, 3, 4, and 1 over. And there's my line. All right, guys. Hope this is making sense. You know where to go. If not, see you at tutorial.